Hello students, welcome to another machine learning video tutorial. Today we are looking at building a machine learning model that will automatically classify a document, whether it is related, the text in that document, whether it's related to a certain category or class. Okay, and we're going to be using naive Bayes classifier in this example. Today we are using VS Code. We're going to be operating in our machine learning environment or Python environment. So we should have VS Code up and running. And what I'm going to do first is I'm just going to create a new file called naivebayes.py. And we are ready to go. So we want to make sure this file is inside our folder with our Python environment. And of course, we do that just to make sure that our dependencies are separate from other projects. Okay, but you can see we have all of our prior code labs in there as well. Okay. All right, so we're going to get started by importing the necessary libraries. And we're going to start with pandas. So of course, pandas is used for data manipulation and analysis. We use it primarily for creating data frames. We're going to use the sklearn library. And of course, this is how we get our naive Bayes model. And from naive Bayes, we're going to import the multinomial naive Bayes classifier. Okay. All right. We're also going to import from sklearn what's called, this is a feature extraction module. And I'm going to use text basically because what we're going to do is we're going to create a Python data dictionary of documents, and we're going to be able to map those documents, the words in those documents, to targets or output. So indeed, this is a supervised learning algorithm. We are going to classify whether a document can be classified as related to one category or another. Okay, so we're going to keep it simple. We're going to have two classifications. And from this feature extraction text, we're going to import what's called the count vectorizer. Okay, what the count vectorizer does is it will convert documents to word vectors. Okay, and we'll talk more about that a little later. We're also going to look at metrics. So from our model selection, from our metrics module, we're going to import the accuracy score, and we've done that before. That is born out of the confusion matrix, so you can imagine we're looking at true positives out of the entire count, okay, with accuracy score. And there are other metrics you can look at, like precision, recall, things like that. We're going to keep it simple with accuracy score. Okay. We're also, of course, going to be using train, test, split, because we want to split our data into training and testing sets in order to make predictions. All right, and those are all of our imports. So we have pandas, naive Bayes. This is our model. We're using the count vectorizer again because we have to essentially convert our documents or our words to numerical values. And in machine learning, you do quite often, or the majority of time, convert categorical or ordinal values, so text values, into numbers. Okay. All right, so the next part of this is we're going to create a data object. So this is essentially a data dictionary. And we're going to first create a column head called document. And this document is going to have a number of documents, essentially documents that we will train our model in order to classify new documents or sample documents. Okay, so we're going to create a number of these. Okay, and as you can see, these documents are related to sports and technology. So what we are going to be doing essentially is classifying documents based on whether they relate to either sports or technology. Okay, so we can also make a note of that. But we're not done. So after the brackets here, we are going to create a new heading called category. And this heading is going to map our data or our documents to our classes or our targets. Okay. So for instance, we are going to have two classes. So whether the document relates to sports or technology, 0 is going to represent sports. So if we look at the first document, I love playing football, that relates to sports. So sports is going to, we can make a note here. So 0 is the sports category, and 1 is the technology category. Okay. So that's how we're classifying. It's a very simple example. If you look at the second document, actually, you know what? Let's add another document here. So the new smartphone is amazing. Okay, so we're done with that. So the second document relates to technology since we're talking about a smartphone. The third is a football match. Fourth, technology. Fifth, also technology. And then the last one here relates to football. Okay. So we know this is a supervised algorithm because we have targets or we have labels. Okay. If you were to scale this out and let's say you had a large large data set of documents that you wanted to classify, you would have to have these target labels, essentially data, and you can do that easily with tools like Excel, where you could classify these documents into categories. If you're doing email spam detection, you can look at classic spam emails and categorize them as spam or not spam. Okay, but we should have everything outlined here. Okay, so our data dictionary is done, and this data we are going to feed into the model. So we're going to use pandas now to create a data frame. And again, data frames are essentially tabular style two-dimensional essentially a two-dimensional matrix. And we're going to feed that in there. And now if you were to print that, and actually let's go ahead and do that. If we print that, just save it now and let's run it. Oh, so we have, sorry. What we need to do is we need to start our environment. And you can see, if you recall how to start that, we have backslash or dot backslash env scripts with a capital S, and then we'll go activate. Okay, so there again, we want to activate our Python environment. Okay, so we're going to go ahead and run that, and we can confirm that visually with this env prepended there. And now we should be able to access all of our dependencies there. So let's go ahead and run it again. Excuse me. Oh. Let's see here. I'm going to guess that we just have an issue with the data dictionary. If it's not formatted correctly, it can have issues. So let's just make sure everything's good. We have all of our commas. Oh, and you can see after the new smartphone is amazing, I forgot a comma. That's why it's not running. So make sure you have commas after all these documents. And you can see here, Pandas has now created this new data frame, and all of our documents are indexed and also mapped to target variables. So we know if 0 is sports, then this document relates to sports, this document relates to smartphones, and so on. Okay, so we have our data. Good. Let's keep going. The next part of this, and we haven't done this before. Oh, I'm getting ahead of myself. We do want to split the data, now that we have it in a data frame, into our X and Y. So our X is our input and our Y is our output, our target variables. So our input, of course, is going to be the document. And I should have put an S for plural, but we're going to leave it at that. And we're going to use convention, so lowercase y now. And this is going to be not our document, but our category. Okay, and we've done this in prior code labs before. So now we have our X and our Y. So we're good to go. And the next part is something we haven't used before. And I'll make a comment. We're going to use what's called count vectorizer. And we know what vectorizers, or vectors are rather, so they could be rows or columns. Essentially, this will tokenize the text. And what that means, essentially, it'll create what's called a binary vector. Okay, representing the presence 1 or absence 0 of each word. Okay. All right. So basically what it's doing is we will one-hot encode using count vectorizer the data based on the presence. Okay, so we don't feed in machine learning, we don't feed textual or categorical or ordinal data into a machine learning model. We often have to vectorize it or one-hot encode it, series of ones and zeros, a representation of that data or these documents. Okay, and that's why we use count vectorizer, and we'll see a visual of that. So the first part of this is we have to create a new instance of this vectorizer. So we're going to go count vectorizer. And we're going to set binary to true because indeed we do want binary values, or we essentially want ones and zeros. So creating a new instance. And now we want to convert our X or our inputs using this. So we use the vectorizer. We use a method in the vectorizer called fit transform. Okay, and we pass in our X, which we've defined up here as the data dictionary or the document column. Okay, so to really get a sense for what this is doing, we want to print this vectorized data. Okay, so we're going to save that now, and we're going to run it. Okay. So we have X vectorized. We have to actually go to array because we want to see what's called the dense format just to get a more intuitive idea of what's going on. And if you run it, you can see our documents now. So I love playing football, the new smartphone, and so on. They've been converted to binary vectors, essentially word counts. So what this count vectorizer uses what's called the bag of words model. And I do have a, let's see, I do have a link that I'm going to share with students. But essentially it works off the bag of words model where it counts essentially the frequency of words occurring in a document. So in this illustration here, you can see the red dog. It will count those occurrences in the document accordingly. And so essentially it will count the frequency, put it into a matrix, and this is what we're going to feed into our machine learning model. And you can see it here. Okay. All right. And that is it for vectorizing our input data. Okay. And you can go over the fit transform method. Okay. In the documentation. But that link that I will include, students can kind of go through it and learn more about the bag of words model. Okay, but just note, we should note here that this binary true ensures that we get a one hot encoding style matrix. Okay, and we can actually do this manually, but because we have imported count vectorizer, it does it for us. Okay, and if you're dealing with a very large data set, you do want that automation. Otherwise, it can be very tedious. Okay. All right, the next part is we're training, or splitting rather, the data into training and test sets. And we've done this before, so X train, X test, Y train, Y test, and this is equal to train test split. And we're going to pass in our X vectorized data. Okay, whoops. VS Code can sometimes have a life of its own. We're going to pass in our Y. Our test underscore size is going to be 0.2 or 20%. So 80-20 split. Oh, I should put a 0 in there. And we are also going to use the classic random state, and we're going to set it to 42. So that's, students by now should have, or be accustomed rather, to having a random state of 42. So this deals with just sampling and ensuring that we're getting good samples that are random. Okay. Okay, so again, this train test split will return a tuple with these variables. Okay. All right. So let's keep going. The next part, and always in these machine learning models, let's save it just to be sure, is we have to initialize our model. Whoops, this is supposed to be a comment, so let's put a pound symbol there. Okay, and so you want to be descriptive as possible. We're going to initialize it like so. So we're going to name a CLF, and this is going to be equal to our multinomial NB, or naive Bayes classifier. So here's our model, instantiated, excuse me. And the naive Bayes, again, students have learned it. I have included the lecture for naive Bayes. Again, this is named after Thomas Bayes, describes the probability of an event based on prior knowledge of conditions that might be related. Okay, it's commonly used in text analysis or spam detection, things like that. There's the equation. Naive Bayes is called naive because it assumes each word or feature is independent of each other. So it doesn't really look at context. Okay, it looks at these keywords or features individually, okay, and how they relate to a certain condition, such as spam or non-spam. Okay, it's simple and fast, works well on large data sets for text classification. And in this lecture, there is also an example that students can go through. Okay, but we're going to continue on. Okay, we must keep in mind with naive Bayes, it's used for text classification problems where features represent frequencies of words. Okay, so in our case, when we converted our documents to vectors using one-hot encoding or count vectorizer, that essentially converted the data or documents into frequency counts. Okay. All right. So now usually after this initializing, we have two methods. If you recall, we'll have fit and predict. Okay. All right. So we're going to start with predict. So let's make a note here. So train the classifier with the training data. Okay, so let's go ahead and call CLF again, and we're going to call fit. And we'll have X train and Y train. Just like that. And save. Okay, and then normally after fitting, we call predict. Okay, so excuse me one sec. Yes, we want to make predictions now on the test set. So let's create a new variable. So y_predict, or PRED, and this is equal to CLF predict, and we always throw in the test set. Okay. And save. All right, so we have I should always capitalize these comments for good measure. All right, so that is pretty basic as far as an implementation of any machine learning model in Python. But I guess the difference would be this count vectorizer transforming the data into word frequency counts and how it uses naive Bayes. So there's a lot going on underneath the hood, and that's why I've included the PowerPoint presentation and that link to the website, because we really want to understand naive Bayes and also how this count vectorizer works. So we're going to try and output as much stuff as we can along the way. All right. The next part is evaluation. So I guess we can make a common. So we want to calculate the accuracy of the model, and we are going to use the accuracy score. And this just takes in our y-test and actual predictions. Okay, so y underscore prediction. Okay, so again, we're measuring, the difference between our predicted values and our actual values. Okay, and the accuracy, and then we can print that out. Accuracy of the model. And we'll throw in our variable. We could do this differently, and we can just have an F string. And with the F string, you could just throw in some curly braces here. And that should work. Okay, so if we save that, we should stop now and actually run it. Oh. Where am I getting that error? Oh, some sort of issue there. Let's save it and let's run it again. Oh, actually, you know what? Let's do this instead. Save that. And okay, I have some sort of syntax issue, but you can see here. Oh, sorry. Let's get rid of the brackets. There we go. Okay, so the print accuracy of the model, and it's showing an underline. Why is it showing an underline? Let's see if I have some sort of issue that I'm not seeing. Excuse me. Okay, let's do that again. Start from the top. Okay, let's go accuracy of the model. Did I forget a comma? I might have forgotten a comma. Yeah, I believe so. Don't forget that comma. Okay. Let's save. And now I've gotten rid of that red mark. So I just want to see what seems to be the issue, and I'm sure it's somewhere around here. So let me just cancel out. I'm going to get rid of this terminal, and I'm going to create a new terminal. All right, and looks like I'm going to have to reactivate my environment. Okay, and save. Now let's run it. There we go. So just a slight hiccup. I'm not sure what the issue was, but as with all software development, you can run into some issues here. Okay, I just need to make sure I'm still recording. I believe I still am. Okay, I just can't see the share button. Oh, there it is. Perfect. Okay, so some slight hiccups. But you can see our accuracy score is actually 1. So 0 to 1, 1 representing 100%. So it's pretty accurate. It's very basic. Obviously, we are just saying, okay, well, if there's a presence of the keyword football or smartphone or technology, it's going to either be sports or technology classes or categories. Okay, excuse me, but we're not done. So let's keep going. The next part is we want to throw in some sample data. Okay, so we're going to create 2 new documents. and classify them either as sports or technology related documents. Okay, and we're going to call it sample underscore documents, and this is equal to, you guessed it, we're going to start a new, in this case it's going to take on the form of a list. So football fever grips the nation, and then we'll have another document, exciting new smartphone launch event. Perfect. So that's our new document. You can, this is a very basic example, but if you fed in, thousands of documents or just a large amount of text data, obviously it would be more efficient to do that than manually eye it and then classify it that way. Okay. All right. But just like we did with our data object here, our documents, we have to convert these sample documents to vectors or binary vectors. Okay. So let's go ahead and do that. And let's make a note. So convert the sample document into binary feature vectors, just like we did up above. Okay, because that's what our model expects. So we're going to be using count vectorizer. So we're going to have sample x documents is equal to vectorizer, and if you remember up above, we use the transform or fit transform. And we're just going to throw in the sample documents. All right. And we want to see what this is doing. So let's print this out. Let's save it and print it out. And we want to run it. Okay. Oh, sorry. So we get that, but this is condensed format, so we do have to use the method toArray. Save that, and let's run it again. Okay, we have a lot of print statements going on, but you can see this is the results of our efforts here. So our sample documents, there's two. This has been converted to a word frequency document, or binary feature vector, in other words, okay? Because this is what our model suspects. So our training data, or our data that we use to train the model, is here, and we converted it to the same thing. So any new documents that we're feeding into the model, we would have to do the same thing, okay? All right, so that's good. Let's keep going. So now we're going to use the train model. So our model is trained to predict the category for these new documents. Okay, and how we do that is let's create a new variable called predictions, and this is equal to our model predict. We're going to pass in the sample x documents, but keep in mind these are vectorized into binary feature vectors. So let's save that. Okay, and actually we are complete. We've set up our data, we've trained our model with naive Bayes classifier. We had an accuracy score, and we're feeding in new sample documents. So if you save that and run it, oh, sorry, we have not printed that. Okay, so let's go ahead and print. I'm getting ahead of myself here. Predictions for the sample documents. And don't forget that comma, or you can use a formatted string or an F string. Let's save that. Now let's run it. And you can see we have our predictions for sample documents. Sorry, I spelled that wrong. Save. Whoops. Let's run that again. There we go. So we have 0, 1. So what does that mean? If you recall from the very beginning, we have two classes or categories, 0 representing sports, 1 representing technology. So if you look at our sample documents now, the first document is football related, so that's related to sports. So this first number is 0, sports, so that's correct. And our second document is related to technology. So we have a 1, so it's classified that as technology. So altogether, this model is working on this new data or these sample documents. And if you could envision as developers how we can scale this out on any sort of text classification, massive amounts of text, how efficient that would be, or email spam filtering. The applications would be pretty broad, okay? And even though it's only 64 lines of code, there is a lot going on, and Python does a great job of abstracting away a lot of the complexities with the sklearn libraries like naive Bayes, the metrics, train test split, and this count vectorizer, okay? All right, so I hope students enjoyed this video tutorial. Just make sure you've saved everything and you save it as a Python file or a text file and submit it at the submission link. I hope you enjoyed, and we'll see you next time.